All right, so let's talk a little bit about deductive argument forms. I typically use some basic deductive argument forms when reconstructing arguments in my lectures, in my intro level classes. Sometimes I have students in those classes learn how to use and use these argument forms to reconstruct arguments themselves, especially in order to earn higher grades in the course. Certainly, in order to earn higher grades in the course, you'll need to be able to recognize deductive versus some basic invalid forms versus some deductively valid forms. So let's go over a few of the forms that you'll see me using and that you may be learning to use in class. So there are 5 deductively valid forms that you'll see me using mostly. Modus ponens, modus tollens, disjunctive syllogism, and big constructive dilemma. Hypothetical syllogism there. So there's 5 of them. Modus ponens means mode of affirmation. Modus tollens means mode of negation. And again, these are all valid forms of deductive argument or rules of inference, as they may be called in some texts. So obviously, we're going to contrast valid forms with invalid forms, which are also formal fallacies. So again, what we're worried about here in this little presentation are just these basic valid forms. And each one of these 5 forms is a valid form. So mode of affirmation, abbreviated MP for short, modus ponens. So here's an example of a modus ponens argument. We've got if P then Q, if Martin Luther King was assassinated, then he is dead. Martin Luther King was assassinated, thus Martin Luther King is dead. So this is an example used in one of the textbooks I sometimes use. And as they note in the text, we use P, Q, R, and S, lowercase letters, as placeholders for parts of propositions. Sometimes you'll see in formal reconstructions an abbreviated letter, a letter or a phrase abbreviated to use as a uppercase placeholder for actual arguments. But here we're just using our little placeholders. So this Martin Luther King argument has the following form. Again, this is the modus ponens form. If P, then Q, P, therefore Q. And notice what happens here. We've got the antecedent, which is P. It's said to imply the consequent Q. And then we have the affirmation in the second premise, line 2 here. We have the affirmation of P. That allows us to derive Q as our conclusion in the third line. So modus ponens is mode of affirmation. Whatever's in the antecedent spot, the P spot here, is the antecedent. Q is the consequent. And then we have the affirmation of the antecedent, which in this case is just P. Again, that allows us to derive the conclusion, the consequent as the conclusion of that argument. So pretty basic little argument form there. Now let's look at modus tollens, mode of negation. If Great Britain won the Revolutionary War, then the United States is still subject to British rule. The U.S. is not still subject to British rule. Thus, Great Britain did not win the Revolutionary War. This argument has a negation involved in it. Right there is the negation in line 2 of the consequent that's in line 1. And that allows us to derive the opposite of the antecedent as the conclusion. So again, that argument has a basic underlying form. First, it begins with another if-then statement, another conditional statement where we have an antecedent implying the truth of a consequent. Then we have the negation of that consequent. So there's the relationship to pay attention to is here we have Q and here we have not Q. And then that allows us to derive the negation of the antecedent. Here's P, the antecedent, and here's the negation of that antecedent as the conclusion. Disjunctive syllogism. So arguments that involve not a conditional statement, but a disjunctive statement. So either George Washington was the first U.S. president or Abraham Lincoln was the first U.S. president. Lincoln was not the first U.S. president. Therefore, George Washington was the first president. So in this argument, we have two options, either George Washington or Abraham Lincoln, right? And then we have the negation of one of those disjuncts as in the simple premise, the second line here, and that allows us to derive whatever disjunct was not negated as the conclusion. So really that ought to be blue there, right? And then here's the negation of the second disjunct in premise 1. So again, we have an underlying form here, either P or Q. So notice it's not an if-then statement, it's an either-or statement. So an disjunct is when it offers exhaustive and mutually exclusive options, then it's a true disjunct, and you really got to pick between either of those two options. That's all there is. Then we have the negation of one of those disjuncts, and then whatever's left over, whatever's not negated, that's the conclusion. So again, we have two options here. We have either P or Q. Then we have the negation of P, which is just not P, right? And that allows us to derive the disjunct that was not negated as the conclusion. So again, another little basic argument form. Then we have big constructive dilemma. It's kind of the biggest, most complicated version of an argument that you'll see me using, although I should point out that you can combine deductive forms to create very complicated arguments, but just in terms of the basic form of the argument, it's the most complicated one. So here we have, again, a disjunct. Either tobacco advertising is curtailed or teenage smoking increases, so P or Q. If tobacco advertising is curtailed, then cigarette companies will have to lay off workers. They'll have less revenue, so they'll have to lay off workers eventually. Then if teenage smoking increases, then cancer rates will rise. Since more people will be smoking, lung cancer rates will go up. Thus, either manufacturers will lay off workers or lung cancer rates will rise. So here, again, a little bit more complicated of an argument, but not too bad. We start off with a disjunct. Either we're going to curtail advertising, or teenage smoking is going to increase. Then each of those disjuncts in premise 1 becomes an antecedent in a different conditional premise. The antecedents in 2 and 3 respectively. And each one of those implies a consequent again in premises 2 and 3 respectively. And then each of those consequents becomes a disjunct in the conclusion. So again, this argument has a basic underlying form, either P or Q. If P, then R. If Q, then S. Thus, or therefore, either R or S. So again, notice what happens here. We have two options. Each of those options becomes an antecedent. Each of those disjuncts becomes an antecedent in two different conditional premises, 2 and 3 respectively. Then each of those antecedents then has an implication, R in premise 2 and S in premise 3, and then each of those consequents in 2 and 3 becomes a disjunct in the conclusion line of the argument. And then lastly here we've got hypothetical syllogism. So this argument is comprised of 3 lines, 3 basic lines, each of which is an if-then statement, a conditional statement, or a hypothetical statement. So if infanticide is immoral, then late-term abortions are immoral. If late-term abortions are immoral, then early-term abortions are immoral. If infanticide is immoral, then early-term abortions are immoral. So a lot of people arguing over abortion these days. Here's an abortion argument put in a valid form. Our only question is whether or not it's sound. So that's a matter of assessing the truth of the premises. Once we know it's a valid form, this argument has the following underlying form, again, made up of 3 conditional lines, and they're linked with one another. So first, let's start off with, we have a if-then statement. If P implies Q, then notice we have Q, which appears as the antecedent in line 2, and it was the consequent in line 1, so that's linking together the antecedent from 1 and the consequent in line 2. And then the conclusion line, right, is if P, then R. So we have if P, then Q, if Q, then R. Thus, if P, then R occurs, because we know that it's linked by that shared common proposition that appears again in the consequent in one line and the antecedent in the next. So then I mentioned that, arguments can get pretty complicated. Those are the 5 basic forms you'll see me use in this semester and that you'll be using this semester. But you can combine these forms to make very complicated arguments. So here's an example of a complex multi-stage argument that links a modus ponens and a disjunctive syllogism together. So what happens here is we've got lines 1 through 3 are the first stage of the argument. We've got premise 1, premise 2, and then conclusion 3, line 3 there. And it's just a modus ponens argument. If P, then Q, P is affirmed, modus ponens, mode of affirmation, thus not Q. I should have said not Q here as well. Both are not Q, right? So again, whatever is in the consequent spot is derived as the conclusion, so long as the antecedent is affirmed, right? And then this first stage of the argument, line 3, just functions like now a new premise. So it's a subconclusion in this 2-stage argument. It's going to function like another premise. So lines 3 through 5 form another argument to the final conclusion, line 5, with a disjunctive syllogism. And so here the premises are inverted from the basic form that we learned. We have not Q, and here we have the opposite of Q. Let me do that in blue. 2 lines for negation there. So there's the opposite relationship, and that allows us to derive this R as the conclusion. Again, using a modus ponens and a disjunctive syllogism together. So long as the sub-arguments are all valid, then the complex argument will be valid as well. Here's another example. Say you were given lines 1 through 4 and told to solve for S. So we need to get S by itself. We see that we've got lines 1 through 4, which are if P then Q, P, if Q then R, if R then S. And so we need to solve for S. How do we get S out as the final conclusion? Here's S in that argument right there, line 4. So if I had R by itself, then I could get S out by itself. There's R. Let's use a different color. Here's R right there. but R is not by itself. It's in a consequent spot, so I needed a Q to get um, R out by itself. Well, here's Q as well, and it's in the consequent spot of an if P then Q, and then line 2 is the affirmation of that antecedent right here. So that could give us line 5. Line 5 is going to be Q, right? Through lines 1 and 2, there's modus ponens form. And then once we have Q out by itself, I can get R out by itself by lines 3 and 5, again using modus ponens. And then I have R by itself, again using modus ponens in lines 5 and 6. I can get line 7, which is our final conclusion there. So again, a multi-stage argument, this time using three instances of modus ponens to get to the final conclusion. All right, so next up, you'll be taking a look at how to evaluate deductive arguments. One step is determining whether they're valid or invalid, and we've just learned 5 basic valid forms. But you need to be able to test for validity and invalidity. So in the next video, you'll be looking at the counterexample method for invalidity, for testing invalidity. For now, get started learning on those basic valid forms of deductive argumentation. We'll see y'all in the next one.